Welcome, automotive apprentices. Ready to dive into this explainer on the fundamentals of vehicle body and chassis types, whether you're gearing up for the showroom floor or, getting your hands dirty in the workshop. Understanding the structural foundation of the vehicles you work on is absolutely essential. Today, we're going to build your knowledge from the exterior shapes you see every single day all the way down to the vehicle's hidden structural skeleton. Let's get into it. So here's our roadmap for today's session. We're going to start off with light vehicle body types, then move into passenger service vehicles, and size up to heavy goods vehicles. After that, we'll strip away the metal for vehicle body construction, and finally, we'll explore chassis frames and sections. All right, Module 1, light vehicle body types, everyday shapes. Think about the classic shapes you see on the highway. You've got your saloon, also known as a sedan. Picture an enclosed passenger compartment designed for 4 to 5 people, with a completely separate luggage space, the boot, tucked away in the rear. Now contrast that with a coupe. A coupe features a rigid, closed roof, only 2 doors, and a much tighter 2+2 seating setup, meaning 2 main seats up front and 2, pretty small seats in the back, usually just for the kids. Coupes are really built around performance, often packing high-power engines for sports and racing. Now, what if we take that saloon and adapt it for urban practicality? Boom, you get the hatchback. While the saloon has that totally separate boot, the hatchback replaces the enclosed trunk with a 3rd door. That's the tailgate, hinging right at the roofline. This clever design allows the roof seats to fold down, basically trading some rear passenger comfort for flexible, bulky cargo space. It sits right in that sweet spot between a saloon and an estate car, making it smaller and, honestly, incredibly easy to park. But what if you absolutely mean to maximize interior volume for, say, 7 to 8 passengers? That's where we look at the MPV, or multi-purpose vehicle, often called a minivan. MPVs are uniquely designed as a monobox, or a one-box shape. If you picture it in your head, the engine is mounted very close to the front edge to maximize cabin space. The seats sit up higher than in a standard car, and they use highly precise seating configurations, like a 232 or 223 layout from front to rear. It really is the ultimate family hauler. Wrapping up our light vehicles, let's compare the estate, or station wagon, to a light goods vehicle, or LGV, like a pickup. The estate extends the passenger roof completely to the back of the car. This gives you massive internal capacity for bulky loads, long family trips, or even serving as an ambulance. A pickup, on the other hand, is a light truck designed primarily for hauling goods. Picture an open-top rear cargo area that is purposefully separated from the front cab. Why do that? Well, it allows the chassis to flex independently under heavy strain without tearing the vehicle apart. So to recap our first module, light vehicle body shapes are dictated entirely by the engineering trade-off between passenger comfort, passenger capacity, and cargo needs. Moving right along to Module 2, passenger service vehicles, or mass transport. It's fascinating how the engineering shifts based on the length of the journey and passenger flow. Single-deck buses prioritize maximum capacity in minimum road space. They carry up to 40 people and use dual doors, one for entering, one for exiting, just to keep foot traffic moving smoothly. Double-deckers, sometimes called omnibuses, are built for high-density, shorter trips. They rely on a transversely mounted engine, meaning it sits sideways across the back to maximize interior floor space and make room for stairs. Finally, coaches are built for considerable distances. They utilize front-facing seats, a single front entry, and large paneled windows for panoramic visibility. To recap Module 2, PSV design is ultimately governed by the efficiency of passenger flow and the specific duration of the journey. Let's scale things up even more with Module 3, heavy goods vehicles or commercial transport. Picture a rigid truck layout where all the axles are bolted to a single continuous ladder chassis frame. Both the body and the cab are attached to this one separate chassis. And here's the key detail to visualize. The cab is positioned partially over and ahead of the front steer axle. In the industry, we call this a forward-controlled driver's accommodation. So, what's the trade-off with this cab-over arrangement? Well, placing the cab directly over the engine maximizes the length available behind the cab for carrying goods and gives the driver superior forward visibility. It also shortens the wheelbase, which allows for longer trailers. But the flat front face completely ruins the aerodynamics. It creates a much noisier ride since the driver is literally sitting right on top of the engine. And, most critically, it lacks a safe forward crush zone in the event of a crash. Now imagine a different setup, the articulated truck, commonly known as a semi-trailer truck. Instead of a single rigid frame, you have a towing engine, the tractor, pulling a separate semi-trailer. You have to imagine the front end of the trailer's chassis resting on the rear of the tractor, swiveling on a crucial pivot point. We call this the fifth wheel coupling. This coupling is located just forward of the tractor's rearmost axle, which means a fraction of the trailer's weight is carried heavily by the prime mover itself. Contrast that cab-over design with the American-style conventional truck. Here, the engine sits ahead of the driver with a distinct, protruding nose, much like a typical car. This provides way better aerodynamics, a smoother ride, and a lot more legroom for those cross-country hauls. To summarize Module 3 on HGVs, sheer load capacity and cab placement dictate whether a truck uses a continuous rigid frame or relies on a swiveling articulated coupling to get the job done. Alright, let's peel back the metal. Module 4, Vehicle Body Construction, focusing on structural skeletons. First up, we have the monocoque, also known as an integral or unitized body. This is entirely frameless construction. The pillars, rails, sills, and panels are all stamped and welded together into a single cohesive shell. It's exactly what you see in those monobox MPVs we talked about earlier. This integral construction produces a vehicle that's stronger and lighter, and it's actually far cheaper to produce when you're manufacturing large numbers of similar units. Conversely, we have non-monocoque, or body-on-frame construction. Just like it sounds, you mount a completely separate body onto a rigid steel ladder frame, and that frame supports the entire drivetrain. This is the absolute standard for trucks, large buses, and older heavy cars. Why? Because it allows manufacturers to drastically change the exterior body design without ever having to alter the underlying mechanical chassis. Pretty smart, right? If you were to look closely at a detailed integral body layout, you could visualize how a modern car uses a reinforcing channel section underframe integrated right at the front. The roof, the floor pan, the wheel arches, in a monocoque, they are all load-bearing. So to quickly recap Module 4, modern passenger cars combine the frame and body into one unit to save weight and streamline mass production, while commercial vehicles rely on strict separation for pure brute strength and versatility. This brings us to our final stop, Module 5, chassis frames and sections, the actual physics of the metal. Imagine a ladder made of heavy-duty steel. This is the ladder frame, the simplest and oldest of all vehicle designs. It utilizes two continuous longitudinal rails running straight from the front of the vehicle to the rear, connected securely by bridging cross members. Because those main rails are continuous, they offer fantastic beam resistance, meaning they're capable of holding up massive engines and heavy cargo without bending. But it does have some severe engineering constraints. First off, the vehicle's overall height dramatically increases because the passenger floor pan has to sit completely above the frame rather than being tucked inside it. More importantly, without properly engineered cross members, this simple perpendicular ladder design suffers from very poor resistance to torsion. Basically, it's highly susceptible to warping and twisting under stress. We need to think about the invisible forces acting on the chassis. You have static loads, the sheer weight of the components and passengers pushing straight down, causing a bending action or sagging across the frame. Then you have dynamic road shocks from hitting bumps or potholes. This causes twisting, or what engineers actually call lozenging. Picture it pushing a rectangular frame into a skewed parallelogram shape. To combat these bending and twisting forces, without just adding massive, solid blocks of heavy metal, engineers utilize hollow, highly specific cross-section shapes. A flat piece of steel, that offers very little resistance. But roll it into a tubular section, and it provides excellent resistance to torsion. Fold it into an enclosed box section, and you get good resistance to both bending and torsion. Keep it open as a deep channel section, and it provides vital, excellent resistance to bending forces. Capping off our final frame module, it's crystal clear that the physical geometry and shape of the metal is just as critical to the vehicle's survival as the material itself. You've now traced the evolution from passenger comfort down to the bare metal twisting under load. But I want to leave you with this final thought to ponder before your next workshop session. As automotive technology rapidly evolves and we start dropping massively heavy electric vehicle battery packs into these frames, completely changing the center of gravity, how will the skeleton of the vehicle have to change next to support those entirely new dynamic loads? Thanks for tuning in to this explainer. Keep asking questions, and I'll see you in the shop.